Week 2, Advanced Database Systems. Course Objectives. In this presentation, you will learn how to investigate the importance of database design and examine how data models can be classified by levels of abstraction. Creation of a data model is a key step in the database development process. Users are interviewed to determine how the proposed system will be used. A model is an abstraction of a real-world object or event. Data models are valuable for database design because they serve as a communication tool. They give an overall picture of the database, they organize the data for various users, and they are an abstraction for the creation of a quality database. Data models are a simple representation of a complex real-world data structure. And data modeling is the process of creating the data model. A data model represents the entities, attributes, relationships, and constraints of the database needed to support the user requirements. An entity is a unique and distinct object used to collect and store data. Attributes are characteristics of entities. Relationships are connections between database entities. And constraints are restrictions imposed upon the data. An entity, a unique and distinct object used to collect and store data. An example of an entity is customer. An entity may eventually translate into a database table. Attribute. Attributes are characteristics of entities. Attributes may eventually translate into fields of a database table. An example of an attribute might be a customer ID, a sales date, an inventory number, or a sales amount. Relationships. A relationship describes the connection or association between entities, between database tables. A relationship matches data in fields, usually a field with the same name or similar name in both tables. There are 3 types of relationships: one-to-one, one-to-many, and many-to-many. In a one-to-one relationship, each row of one table is associated to exactly one row of another table. The number of rows in each table will be the same. In this example, the customer table is associated with the customer email table. For every row in the customer table, there is one row in the customer email table. The one-to-one relationship is rarely used because the tables can be merged into one larger table to achieve the same result. The benefit of the one-to-one relationship is to improve performance of the database. If a query is performed on the whole table, a one-to-one relationship permits a smaller table and quicker query performance. In a one-to-many relationship, each row of one table is associated with many rows of another table. This is an efficient storage method because the related record does not need to be stored multiple times. For example, all of the customers for a business is stored in a customers table, while all of the invoices are stored in an invoice table. Each customer can have many invoices, but each invoice can only be associated with a single customer. The many-to-many relationship is an indirect relationship requiring a third table called a mapping table. One or more rows in one table is associated with 0, 1, or more rows in another table through a mapping table. For example, all invoices are stored in an invoice table, while all products are stored in a product table. Each invoice can have many products, and each product can be assigned to many invoices. The mapping table can be the invoices line items table. Constraints are restrictions imposed upon the data. Constraints include making data mandatory and requiring unique values. Constraints also include establishment of the primary key and indexes. The primary key is an attribute that uniquely identifies a table. For example, a customer ID field may serve as the primary key for a customer table. Establishing one or more attributes as indexes will improve performances of queries. Fields that may be used frequently as search fields can be selected as index constraints. Numerous types of data models exist to support the development of a quality database system. In an effort to promote a better understanding of data models, the American National Standards Institute Standards Planning and Requirements Committee defined a three-level framework for data models based upon degrees of data abstraction. Degrees of data abstraction refer to the level of detail provided in the data model. Three levels of abstraction offer increasing detail: external, conceptual, and internal. Offering the highest level of abstraction, the external model describes the database for a particular group of end users. Most users do not require access to the entire database. The users can access data in a way customized to their needs. Parts of the database that the user does not need are hidden from the user. The conceptual model describes the logical structure of the database. It defines the entities, relationships, and constraints of the data. The conceptual model offers a global representation of the database, including the information that is going to be represented in the database. The internal model offers the lowest level of data abstraction. It maps the conceptual model to the selected database management system. The internal model defines how the data is stored in the database. The internal model defines how the data is physically stored and organized. It defines indexes, encryption, and record placement. An additional type of model which operates at the lowest level of abstraction is the physical model. It describes the way the database is stored on storage media. The type of data model that we will focus on in this class is the entity relationship model. It is a graphical representation of entities and their relationships in a database structure. The entity relationship diagram uses graphical representation to model database components. three primary styles of entity relationship diagram modeling notation exists: CHIN, Crowsfoot, and UML class. The first set of symbols show the one-to-many relationship. The second demonstrates the many-to-many, and the third the one-to-one. Next, using Microsoft Access, I will demonstrate some of the concepts discussed in this week's materials. I will be demonstrating in Microsoft Access 2013, but any of the versions of Microsoft Access will be similar. Notice under Tables, I am showing there's 4 tables: Employee, Job, Region, and Store. I'm going to open the Employee table by double-clicking on Employee. Notice I have several fields: Employee Code, Employee Title, Last Name, First Name, Initial, Date of Birth, Job Code, Store Code. The collection of fields creates a record. This is a complete record for John. And this collection of records creates my employee table. To move into Design View, I click on the Design View button on my toolbar. It shows me details about each field. Notice the naming convention of my fields. The field has a prefix of the table. This field is a foreign key to the job table. So the prefix is actually job, even though it exists in the employee field. The data type is listed here, and the property for each field is listed below. Some things to look for. Under Employee Title, notice it has an input mask. Notice it has a validation rule. There may be other fields with similar constraints. Job code has a default value. Your primary key is denoted by the key symbol to the left of the field name. I'm going to close this table and open the job table and the region table and the store table. Going back to Design View so that I can view the relationships. Here you can see the one-to-many relationships between the tables. You can double-click on the line to view the relationship type. So the information about the tables, the fields, the key, the properties, and the relationships will help you with this week's assignment.